Factor the trinomial completely. 4x to the third plus 8x to the second minus 32x. Okay, what we're looking at here is a polynomial, and we're being asked to factor it. And of course, the nature of factoring, the goal of factoring, the goal is to take the expression that we're being given, in this case it's a polynomial, and express the polynomial in terms of multiply. You know, what 2 at least, or 3, however many factors we can break it down to express this polynomial, which is essentially it's a collection of terms that are connected with add and subtract. But what we're being asked to do is convert it to an expression that's connected with multiply. Okay, that's the essential meaning of factoring, the goal of factoring. So let's copy down our polynomial. And we have 4x to the third plus 8x to the second minus 32x. Okay, well, one of the first things that would be very advantageous to do when we're factoring is find the GCF. Find the greatest common factor of each of the terms. The greatest common factor across all these terms. Well, one of the easiest things to include or exclude from a greatest common factor are variables. Now we see that the variable x appears in each of these three terms. Definitely there's an x in the greatest common factor. A shortcut to the greatest number of x's that could be in common with all the terms is to look for the smallest exponent on x, and that's 1. The most number of x's that could be in common with all three terms is 1. So x to the first belongs in the GCF. Now I want to look at the numbers. Inside of this 4, there's 2 times 2. Inside of this 8, there's 2 times 4. In other words, I'm performing essentially a prime factorization, but I'm going to, for the purposes of explaining GCF, I'm going to go all the way down to prime numbers, and not quite a proper prime factorization with exponents showing. Okay, so 32 is perhaps 2 times 16. Prime numbers in a prime factorization get a vertical line. 2 times 16. 16 is 2 times 8. Now, I can basically stop here because I have a maximum number of 2's from this first term. I have 2 times 2. Here's kind of what I'm getting at. When we're looking for common factors, we want to identify factors that are in common across all the terms, the greatest number of times they appear. So here's a factor of 2 that I can match up with other factors of 2 in the other two terms. And so for each match, I put in one of those. It's like I report one match to the GCF. Then I come back, and we're looking for if there's a greater number of common factors of 2, and it looks like there are. For this other 2, here's a different 2 in the middle term that can match up, and a different 2 in the third term that we can match up. So for the match up of all of those, the second set of 2's, we put another 2 in. There's the G part of the GCF. There's a factor of 2 in common, but there's a greater number of 2's in common. So there's a GCF. And even though there's 2's in common between this 2 and this 8, there's another 2 in that 8. We've burned out all the 2's possible in the first term. They've already both been reported. So we find that the GCF for this polynomial is, multiply the 2's together, 4x. And GCFs can always be positive or negative. There's always 2 GCFs possible. Positive 4x or negative 4x. Okay, I'm going to write a clean copy of the original polynomial that we're being given. 4x to the third plus 8x to the second minus 32x. And then we're going to factor out the GCF. I'm going to write the remaining polynomial. Once we factor out the GCF, we have 3 terms. Okay, there are going to be 3 blanks we need to fill in to make sure that if we factor out the GCF, then when we redistribute the GCF, here's the GCF for this polynomial. when we take this GCF and multiply it in across all these terms, we have everything we need in these blanks to make each of these original terms come back with multiply. So what we're doing now is we found the GCF, and in this second step, we're actually factoring out. We're going to factor out the GCF. The GCF. Okay? Okay, we switch back to green. And the first term of the remaining polynomial here in green, we want it always to be positive. And we're looking up here at the term we're trying to make come back. And it's positive. Here's what I do. I take the GCF and say, when I multiply this GCF times positive to make positive, well, the GCF itself, the sign that we need, is positive. That's how we distinguish between, what should we use, the positive or negative GCF? I float this sign out last, just before I start filling in the first blank of the last decision of which version of the GCF I should use. In this case, I need positive, so that positive times positive makes positive for this term to come back. What else do we need? Numbers now. 4 times an invisible 1 to make this 4. Then x to the first, I need x to the second. I need 2 more x's in here, x to the second, to make add 1 plus 2 from the product rule for exponents to make 3. X is total, x to the third. Okay, now let's distribute this GCF to the middle. Positive times what to make this term come back? Positive times positive to make positive. 4 times 2 to make 8. X to the first, well, we're trying to make x to the second come back, so we need another x in this middle term. And sure enough, it all works out. X to the first times x to the first adds up to x to the second when we do the product rule for exponents. Okay, now we're trying to make negative 32x come back. So positive times negative makes negative. 4 times 8. 4 times 8 makes 32. And we don't need any more x's in this last blank because we have this x to the first already appearing in the GCF. Okay, great. We've now factored out the GCF. However, it's incumbent upon us to try to continue factoring if possible. Try to continue factoring this factoring this remaining polynomial. So the question is, can we continue factoring this green remaining polynomial? And what we ask ourselves is this trinomial, it looks like a trinomial, and it looks like it could be of the form x squared plus bx plus c, but is it? I don't know. Let's write down the form of this trinomial, x squared plus bx plus c, and see if it matches all the criteria. In other words, is there a variable squared in the first term? Yes, there is. Is its coefficient a positive 1? Yes, it is. Now move on. Is the variable that's squared in the first term, does it appear to the first power in the middle? Yes, it does. X was the variable that's squared in the first term. X appears in the middle to the first power. Okay, great. Then when these pluses match, we can identify b as positive 2. Now, we go to the end. So in other words, we're identifying all the parts. So far, so good. If we see a negative 8, is that a constant at the end? Yes, it is. To identify c properly, though, we need to put a plus in to match this plus. I'm using the rule for additive inverse to identify c properly as negative 8. C is negative 8. So we do have this. Yes, we do have this. Then what the method of factoring we should proceed with, we should use, there's many names have been called for the method we're about to use. In class I use the two tables method of factoring. The two tables method. Well, the two tables that we use, you can make two big tables with two giant capital T's. Two big capital T's. The first table, we need to find the factors of c. The c that we identified is negative 8. The second table is the same two factors whose sum is b, and b is positive 2. Positive 2. So here's what we're trying to find. Two numbers that when we multiply them together, we produce negative 8. And those same two numbers, when we add them together, make positive 2. Factors of c whose sum is b. So we proceed to trying to find the factors of negative 8. Now, we could try several things. We're always going to want to start on the factors table, the factors of negative 8. So I'm thinking about breaking these down. 2 times 4 makes 8. And it's always going to be two numbers. The other pair of numbers could be 8 times 1. Now, to make a negative number with multiply, we could have a couple of other possibilities, because we're showing just positives here, but those aren't going to work. Two positives multiplied together don't work. So I'm copying out all the possibilities. To make negative 8, we could have positive 2 times negative 4. Or we could flip the signs and make negative 2 times positive 4. I need a negative times a positive to make a negative. Same would be true for 8 and 1. Either I could have positive 8 times negative 1 or negative 8 times positive 1. So when I look at all of these possibilities, all these four possibilities would work in this first table, but only one pair of them would work in the second table. And you know what those are? Is this pair. When we put this pair up here, negative 2 times positive 4, negative times positive makes negative. 2 times 4 is 8. This pair of factors work in this table. Do they also work in this second table? Negative 2 plus positive 4. Yes, they do. They work. When I have $4, but I owe somebody 2, I take away those 2, and I still have 2. So these numbers work. Now, the way we use these numbers when we're factoring trinomials is we ask ourselves, well, where did trinomials come from? Trinomials usually come from two binomials that multiply together. And when and here's what we mean by that. Two binomials. Binomials have two terms. They're two-term polynomials. You know, when we FOIL these together, we receive a trinomial most of the time. And it's the first partial product in FOIL that make up this first term. So look at this. What would we need in the first blanks to make an x squared? That's essentially x squared. 1 times x squared is x squared. All we need is x times x. And you know how we use these numbers that we found in these two tables, in the two tables method? We just take these numbers and we drop them in. Look, negative 2 and positive 4, whether we use them from the first table or the second, they're the same numbers. We drop in a negative 2 and a positive 4 into these binomials to complete them. I can't leave the GCF behind. The GCF, once we factor it out, is always a factor in the end of factoring. Once it's factored out, we have to keep it. So what we're looking at here are 3 factors in the end. We were expecting 2, but when we factor out GCF, we have a third factor. The way to check these is to FOIL these two. Let's go ahead and do that. Here's a check step now. I'm going to just squeeze it in here. We're going to check to see if our factors are correct. So we have x minus 2 times x plus 4 with a GCF of 4x. The easiest way to check these is to FOIL the two binomials and then distribute the 4x, the GCF, back in. So FOIL x times x, the f in FOIL is x squared. The O in FOIL is positive 4x. The I in FOIL is negative 2x, and the L in FOIL is negative 8. And these are in parentheses. I still have this 4x here. We're just FOILing so far. Positive 4x minus 2x. This is positive 2x minus 8 x squared. Now comes, we're finished with the FOIL at this point. Now we're looking to distribute this 4x to each term and see what we get. 4x times x squared. That would make 4x to the third. Positive times positive makes positive. 4 times 2 is 8. X to the first times x to the second is x to the second. And then positive times negative makes negative. 4 times 8 is 32 and x. So now we're going to compare this with our original polynomial, see if it all came back. Do we have a 4x cubed in the original polynomial? Look, so I'm coming back up here. Yes, we do. That came back by multiplying all of our factors together. Do we have a positive 8x squared in our original? Positive 8x squared. Yes, we do. That came back very nicely. And a negative 32x. Did that come back? Yes, negative 32x. We got all of our original terms back from our polynomial. So these are the correct factors. And what I see here is, first of all, a 4x. Which answers have a 4x as a GCF? Answer A is possibility, and answer C. B and D are not possibilities because they're only showing two factors. I eliminate those as possible answer choices for the correct answer. Then, do we have an x minus 2 factor? We do. Here's x minus 2, right here. X minus 2. We have that. It does not appear. Here's an x plus 2. That's an incorrect factor. I can eliminate answer A. Let's verify answer C by looking for a factor of x plus 4. There it is. To complete this question, we definitely are going to choose answer choice C. It is the correct answer to the problem.